Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempting to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem I'm going to be attempting today is number 1791, find center of star graph. So we're just going to go through the spec here. There's an undirected star graph consisting of n nodes labelled 1 through n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node with every other node. You're given a 2D array edges where each edge indicates that there is an edge between the nodes u and v. Return the center of the given star graph. So you're given 1 is connected to 2, 2 is connected to 3, and 4 is connected to 2. That puts 2 because 2 is the one in the middle. With this one, you've got 1's connected to 2, 5's connected to 1, 1's connected to 3, and 1 is connected to 4. And so in this one, 1 is the middle node because you've got all of these, this 2, this 5, this 3, this 4. They're all coming off of this 1. So really you just need the first two. You need 2 edges, like let's say 4 and 2 and 2 and 3, and from that you'll be able to determine which one's the middle because it'll occur in both edges. So in 4 and 2, 2 will occur, and in 3 and 2, 2 will occur, but you won't have 4 connected to 3 or 4 connected to 1 or 1 connected to 3. So in 4 you won't have any of these other nodes, you'll only have 2, and in 3 you'll only have 2. So you only really need the first 2 edges to figure out which is the middle node. So I'm just gonna go over to my notes here to write down any ideas. So we only need 2 edges to figure this out. 2 edges, let's say it's 1, 2 and 2, 3. So we'd then have to compare 1 with 2 and then 1 with 3 and then 2 with 2 and 2 and 3, and if any of them are the same, or we could sort them. So then we've got 1, 2, and no, that wouldn't work. Need some way to get that number at the beginning. So check if you could just say if 1 not in this, then if this is not in this, then it must be this. So check if so we can check if 1 is in 2, 3. If it isn't, return 2. Okay. So let's just try this. Let's take this code and try and make it work. So I didn't even look at the constraints for this. N is between 3 and 10 to the power 5. What's n here? The amount of nodes. Each length is equal to n minus 1. Okay, that makes sense. Each edge has 2 points, and I know this u1. and V1 is. Oh, I think it's like each number in this has to be between 1 and n, which is it's going to be between 3 and 10 to the power 5, and the edges can't equal each other. Or the points, the vertices, I'm not sure what you'd call them, points, cannot be the same. Okay, so pasting in my code here, just gonna try and do this. So for edge and range, we don't even need to loop through it, we just need to do if edges 0, 0, and edges 1, return edges 0, 0, else return edges 0, 1. Let's try this. These first two cases pass. This could probably be done in one line, but this is simple enough. And hopefully this gets accepted. Accepted, there we go. So, thank you very much for watching the video. I hope it was useful to you in some way, shape or form. If it was, please let me know and leave a comment. Or if you had some other solution that was a bit more simple or efficient, again, please leave a comment. Love discussing these problems and their solutions. So yeah, thank you once again for watching the video, and I hope you have a great day. Bye.